Hello everyone, I am Senapati, Assistant Professor, Vedang History of Technology. So, in this class, we will solve some different kinds of numerical. Okay, so to start this numerical, here we have one section, one chord section of a plane. So, we know that the stresses acting here is sigma x and sigma y is not given here, you can see. And we have one shear stress that will be 3 megapascal. Okay. So, what asked in this question, at a point in a stressed body, the state of stress on two planes, that is 45-degree apart. Okay. So, is as shown below. The angle is given, sigma x is given and shear stress is given. We need to find out what? Sigma y is what? So, to find out the sigma y, here we have another two things, right? What are these? We know that in that chord section, here we are having the whole normal stress, okay, sigma n, that is 2 megapascal, and here is the tangential stress, that is sigma t. So, now to solve, what are the given data? First, sigma x is given, that is 8 megapascal and 8 megapascal in tensile direction. So, we will take that as positive. You can see the shear stress that is in clockwise direction. So, also we will take the shear stress as positive, that is 3 megapascal. Okay. Now, another two things given, that is sigma n and sigma t. Okay. Sigma n is 2 megapascal and sigma t as 3 megapascal. So, to solve this, we know the formula for sigma n as sigma x plus sigma y upon 2 plus sigma x minus sigma y upon 2 into cos 2 theta minus tau sin 2 theta. We have already discussed this formula, also derived this formula. Okay. So, another thing is tangential stress, sigma t. So, your sigma t is sigma x minus sigma y upon 2 into sin 2 theta plus tau sin tau cos 2 theta. Okay. So, if we just take the sigma n formula here, if we just use this formula to find out sigma y, okay, to find out sigma y, then by using this we can get the value of sigma y. Let's solve the equation. So, sigma n is what? 2 megapascal. We can write 2 is equal to sigma x, that is 8 plus sigma y upon 2 plus what? Sigma x, that is 8 minus sigma y upon 2 into cos 2 theta. Okay. So, we know here theta is 45 degree, right? Theta is 45 degree. So, 2 theta will be 90 degree into cos 90 degree minus tau value is what? 3 minus 3 into sin 90. So, we just need to remember some trigonometric formulas. We know cos 90 is what? 0. So, this will be cut. And sin 90 is what? This sin 90 is 1. So, 8 plus sigma y upon 2 minus sin 90 is 1, 3 into 1 as here minus 3. Okay. Next, 2 is equal to 8 plus sigma y minus 6 upon 2. 2 to the 4. 8 minus 6 is 2. 2 plus sigma y. So, sigma y will be 4 minus 2, that is 2. So, we have sigma y as 2 megapascal. Now, what we can do? We can just draw the Mohr circle to find out sigma major and minor. Also, we can use the formula. Okay, I will solve those things in two ways. Okay, first we will use the analytical method, then we will solve by using graphical method. Now we have all the datas. First, we will solve analytical method. So, to find out sigma major and sigma minor, or you can say sigma maximum and sigma minimum, the formula is what? Sigma x plus sigma y upon 2 plus or minus root over of sigma x minus sigma y by 2 whole square plus tau square. Okay, now if we put the value, so we can find out sigma maximum and sigma minimum. Let's solve it. So, sigma maximum will be what? Sigma x is 8 plus 2 by 2 plus or minus 8 minus 2, 6 by 2, 3 square. 3 square plus tau is also 3. So, sigma maximum will be 10 by 2, 5 plus or minus 3 square, 9 plus 9, 18, root over of 18. Okay. To find out sigma maximum and sigma minimum. So, now sigma maximum will be 5 plus root over of 18 and sigma minimum will be what? 5 minus root over of 18. Now, we can just calculate and find out the value. So, if you check, you can get the values here, this one. Okay, this one 9.242 and 0.758. So, another thing, to plot the Mohr circle. Okay, let's plot the Mohr circle. Okay, so yeah, to plot the Mohr circle, we need what? X axis and y axis. Okay. Yeah. Right. So, if we just clear this again, okay, here you will have the x-axis, that is representation of your normal stress, and y-axis is for tangential stress. This will represent sigma, and here it will representation of tau. So, what we will do? In analytical method, we are already having the sigma x and sigma maximum and sigma minimum value. Let's put it in case of graphical method and do solve this. So, sigma x is what? 8 megapascal, 2, 4, 6, 8. Okay. So, here sigma x as 8 megapascal and what? Sigma y, we have already find out it, 2 megapascal. So, your sigma y will be here 2 megapascal. Okay. Now, your sigma, we need to find out the center. So, the center will be sigma x plus sigma y upon 2, 8 plus 2 by 2, that will be 5, 2, 4. So, here it will be your center, and this will be your x and y. By taking x and y as radius, or you can take, okay, here we will take the tau as 3 megapascal. You can see the tau is in clockwise direction, so positive. So, in which plane we are having sigma? We are having tau in x plane. So, we need to plot that positive clockwise here. Okay. So, by taking these to these as radius, okay, let's draw it from x and y. Okay, here we will have the Mohr circle. Okay, so now what? Now you can find out the major and sorry. From this you will draw the point, and here. Here you will have the Mohr circle. Okay. This small circle representation of what? Sigma max and sigma minimums, or you can say, sorry, this line here in this point you will have sigma minimum, and in this point you are having sigma maximum. So, by calculating, or you can add up to this point, this to this point, and you are having here sigma minimum. Here this O to what? Sigma maximum is your value. Okay. Now, we have already solved this question by using both analytical and graphical method. So, next what? Next, let's solve another question. Okay. What is the asked in this question? If the two principal strains at a point are this and this, so then the maximum shear strain. You can see we have solved the questions what asked about stresses, but in this question here it asked about strain. So, in case of stress and strain, there is the formula, let's write it. the normal strain, the normal principal strain is nothing but x plus y upon 2 plus epsilon x minus epsilon y upon 2 into cos 2 theta minus, in case of tau, that is shear stress, we are having here phi upon 2. Tau is equal to phi upon 2. Okay. There is only this much changes in case of stress and strain calculation. Okay. Phi by 2 what? Sin 2 theta. So, epsilon n is nothing but your what? Normal strain. Okay. So, we will use this formula. Okay. Now, to draw the what? Mohr circle. You can see here one is positive and another one is negative. Okay. So, as 1000 here, let's take 200 as 1 unit. Okay. So, here we will have 200, 400, 600, 800 and 1000. Right? Here also 200, 400 and 600. So, our center line will be the whole similar process, minus 600 upon 2. So, we are having 400 by 2, that will be 200. Okay. Here we are having the center line, let us take it as C. So, here to this sigma y point and this sigma x point, we can draw the Mohr circle. Okay. So, what asked? The maximum shear strain. So, if we plot the perpendicular from this, okay, if we plot the perpendicular from this line, we can have the maximum shear strain, right or wrong? Right? And this is your sigma n. Here you are having tau max. Okay, 200, 400, 600 or 800. So, if we draw it in using AutoCAD, you can have the value of tau max and your answer will be what? This will be your answer. You can check this question by using analytical method and you will have this as your value. So, in this class we have already solved two types of numericals, and in our next classes we will solve more amount of numericals to know the methods properly. So, to know those numericals, you need to stay tuned with the class. Thank you so much.